Hi there, I'm going to show you how to solve a 4x4 Kenken, and if you like Sudoku puzzles, you're going to love Kenkens. So here I've drawn a 4x4, so you can see there's 4 squares vertically and horizontally. That's what makes it a 4x4. So step 1, for a 4x4 Kenken, write the numbers 1 through 4 across the top. If this was a 3x3, you'd write the numbers 1 through 3, or 5x5, you'd write 1 through 5, etc. So step 2, I like to identify all the single cages as a given. What's a cage, you ask? If you notice on my drawing, there's a bold line and there's also thin lines. So the cages are indicated by the bold lines. And then the thin lines in between, inside the cage, that's how many numbers there are. So for example, for step 2, the single cages would be one square all outlined in bold. For example, in column 1 on the bottom square, that one is a single cage. And if you also notice in the top left of that, there's just a number 1 there. That means that there's no order of operation. That means there's no equation. And it also says that that's the number that goes inside that cage. So I'm going to put it there. So that now we're going to move on to step 3. So in step 3, I like to write down all the possible equations to satisfy the sum, difference, product, or quotient answers in each cage. And note, pay attention to how many numbers each cage requires. So for example, for the quotient of 2, there are 2 different equations. 4 divided by 2 equals 2, and 2 divided by 1 equals 2. And I'm going to continue going, so the difference of 1, there's 3 equations there. 4 minus 3, 3 minus 2, and 2 minus 1. For the sum to equal 5, the sum of 5, 4 plus 1 and 3 plus 2, the product of 12 can only be 4 times 3. Now remember, we're only using the numbers 1 through 4. And now the product of 6, 3 times 2 times 1. So in a Kenken, each row and each column can have a number 1, 2, 3, and 4 only once. So that's sort of the trick here. So now we're going to move on to step 4. We're going to indicate in each square the possible numbers that they can be. So I'm going to start up. I always try to start in the top column, top square of the first column. So that one can only be a 4 and a 2 because my 2 equations that give me a quotient of 2 only has 1, 2, and 4. However, there is that number 1 down in the bottom of that column. So there cannot be a number 1 in that square. Then I'm going to complete the cage. So this box to the right of the first box, basically the first box in the second column can be a 4, 2, or a 1. So I'm going to write that there. Now I'm going to continue with the first column just so that I can get that finished. And my difference of 1, I actually can have 1, 2, 3, or 4. But like I said, there can't be a number 1, so I won't put it there as an option. So as it's a vertical column, a vertical cage, then the bottom square also can have a 4, 3, or a 2. Now I'm going to go to the third column because it's also a difference of 1 and it's a vertical cage. I'm just going to continue on there. So this one can have a 4 and a 3 and a 1. It cannot have a 2 because the cage beside it is a horizontal cage and that one must have a 2 in either of those squares. So I know by process of elimination, the number 2 cannot be in that square. So these are the 3 possible numbers, although you can have all 4 numbers for the difference of 1. So in the bottom square underneath it, this one can have all 4 numbers. Now I'm going to go and actually in the fourth column, I notice right away that I can have a 2, a 1, a 2, and a 4. However, I notice that there's the vertical cage of the product of 12, and that can only have a 4 and a 3. So I'm going to go ahead and just write the 4 and the 3 in that cage. That means that there cannot be a 4 in the top 2 boxes. So I'm going to just put in my 1 and a 2 up there. I've automatically eliminated the 4 in either of those boxes. So now I'm going to go and I'm going to do my product of 6 because I know that that can be only a 3, a 2, and a 1. So I'm going to go ahead and put that in there. on the bottom row, there cannot be a 1. So those two boxes can only have a 3 and a 2. Now, for my sum of 5, these squares, these boxes, can have all 4 numbers. So this cage I will likely leave until one of the last ones to solve, unless I can do it through process of elimination. And that brings me to step 5. So in step 5, my final step, however there is quite a few steps within, you begin solving each cage or each line horizontally and vertically. So here I'll explain as I go along. So the first thing that I notice right away is that my product of 6 has the 3 and the 2 in the bottom row. And that means that this can only be a 1 in this square. So I'm automatically going to just drop a 1 right in there. So I'm going to remove the 1 as a possibility in the column and in the row associated. The third square that I'm going to take a look at is in my product of 12, because in the bottom row, I know that there has to be a 3 and a 2 in the bottom of column 2 and 3. Then the 3 cannot go in the bottom of row 4, which means that number has to be a 4. I'll go ahead and drop that in there. And that means by process of elimination, the square right above it must be a 3. So I'll drop that in there. So I'll go ahead now and I'll remove the 3 as a possibility in that row associated. So now I notice as soon as I remove the 3 from that first column, third box, that they're right up above it in the difference of 1, that's the only 3 in that column. So I'm going to go ahead and remove the possibility of the 4 and the 2 there and drop my 3 in there. So next, what I'm going to do is remove the possibility of the 3 in that row. And again, I take a look quickly up and down my row and my column that had a 3 removed, and I notice that in the bottom of the second column, there is once again a 3 that is the only 3 in that column. So I'm going to go ahead and drop my 3 in there. So because now this cage, my product of 6, has a 1 and a 3, I know by process of elimination that the last square must be a 2. Perfect. That cage is done as well. So now I'm going to go ahead and I'm going to remove the 2 associated in that column. And that means that the 4 is the only one that can go in that second square in the third column. I'll drop that in there. And now in step 5, what I mean by solving each line horizontally or vertically, I have a 1, a 2, and a 4 in column 3. And in the first box, there's a 4 and a 3. I'm going to get rid of that 4, and I'll drop my 3 in there. So now I have satisfied column 3. Perfect. So now I'm going to take a look and at the number 4 that I had dropped in. And I'm going to notice that in the second row, I didn't remove the 4 in the sum of 5 box. So I'm going to go ahead and remove that right now. And then I'm going to take a look at my equations that satisfy the sum of 5. 4 plus 1 and 3 plus 2. So the cage has a 4 and a 1 and a 2 and a 2. So it cannot be 4 plus 2, and it cannot be 2 plus 2. So that means that this square must be a 1. And the bottom square in that cage must be a 4. Perfect. Now I'm going to remove the 4 and the 1 in that column. And I notice that the 2 belongs in that top square. So I'll go ahead and drop that in there. The next thing I'm going to notice is that in my top left cage, my quotient of 2, I have a 2. So it's not 4 divided by 2 or 2 divided by 2. Well, 2 divided by 2 is 1. So it cannot be 2. It must be 4. So I'll get rid of that 2 and I'll drop my 4 in there. And so now the first column, by process of elimination, I have a 4 in that top square. I must get rid of the 4 in that third square of the first column, and I'll drop my 2 in there. And to verify, my first column has 4, 3, 2, and 1, and then the third row has a 2, 4, 1, and 3. So those are both, as far as I can see, correct. Each row and each column that I have right now only has one of each number. So now it kind of gets a little bit easy. We only have 2 numbers left. And although we have one column and 2 numbers, and they both need a 1 or a 2, so what are you to do? You can just take a look at the rows. So we'll just start by the first row. So we have a 4, a 2, and a 3. So this must be a 1. And now we must have, so we have a 1, a 3, and a 4. That cage for the quotient of 2 must be a 2. And there you have it. That's how you solve a Kenken. They're super fun, they're super easy, they're challenging, they can be hard, they can be you can find them on the internet, online, or you can try to make one on your own. So I hope you enjoyed it, and if you have any questions or comments, please leave them in the YouTube comment chat. Thank you.